Python doesn't have built-in arrays in the traditional sense. It offers two powerful alternatives for efficient data storage and manipulation. 1. Lists. Versatile, ordered collections of items that can hold elements of different data types, integers, strings, floats, etc. Ideal for general-purpose data management and dynamic changes. Created using square brackets. Using lists. Lists in Python are quite flexible and can hold elements of different data types. You can create a list by enclosing elements within square brackets. The list operation in Python include creation of list, indexing list, adding and removing elements from list, slicing list, concatenation and mutation of list items. Using the array module. The array module provides more compact arrays of a single data type. To use the array module, you need to import it first. Creating arrays. You can create an array using the array.array function, specifying the type code and providing the elements. Accessing elements. Array elements are accessed in the same way as lists, using index notation. Modifying elements. Similar to lists, you can modify elements in an array by assigning new values. In Python, arrays are used to store collections of elements of the same data type in contiguous memory locations. They are useful for various purposes, including efficient memory usage. Compared to lists, arrays from the array module use less memory because they store elements of the same data type. This makes them more memory efficient, especially when dealing with large data sets. Numeric computations. Arrays are commonly used in numerical computations and scientific computing tasks. Libraries like NumPy build upon the concept of arrays and provide efficient implementations of mathematical operations on multidimensional arrays. These arrays are crucial for tasks such as data analysis, machine learning, and simulations. Performance. Arrays offer better performance compared to lists for certain operations, especially when dealing with numerical data. Since arrays store elements of the same data type, they allow for faster computations and operations such as element-wise operations, matrix operations, and vectorized calculations. Data manipulation and processing. Arrays are used extensively for data manipulation and processing tasks. They provide efficient data structures for storing and processing large data sets, making tasks such as filtering, sorting, and transforming data more manageable and faster. Image processing and computer graphics. In applications related to image processing and computer graphics, arrays are commonly used to represent images and perform various operations such as image filtering, transformation, and analysis. Arrays provide a convenient way to represent pixel values and perform pixel-level operations efficiently. Embedded systems and hardware interaction. Arrays are used in embedded systems programming and hardware interaction where efficient memory usage and low-level access to data are essential. Arrays allow programmers to interact with hardware components and memory locations directly, making them suitable for tasks such as device drivers, signal processing, and real-time control systems. Network programming. Arrays are also used in network programming to represent data packets, messages, and buffers efficiently. Arrays provide a structured way to handle binary data and byte-level manipulations required for network communication protocols such as TCP/IP, UDP, and HTTP. Overall, arrays play a vital role in various domains of software development, including scientific computing, data analysis, image processing, system programming, and network programming. They provide efficient data structures for storing, manipulating, and processing data, making them essential tools for many programming tasks and applications.